Welcome back to my class. So topic 2 discusses on the sustainability, specifically focuses on its concepts and problems related to sustainability. For your information, IIUM is trying to adapt Sustainable Development Goals, or we call it SDGs, promoted by the United Nations to nurture its graduates. So out of 17 goals listed in the SDGs, 5 of them are related to environment. So the goals in the SDGs that related to our area focus on the climate change, life below water, life on land, clean water and sanitation, as well as responsible consumptions and production. So why do we have to be responsible in our consumption and production? Because if we are irresponsible, definitely we will have the problem with waste generations. But what is sustainability and why it is so important that United Nations make it as the world goals to be achieved? So we will discuss this topic from economics point of view very soon. Okay. These are some concepts on sustainable development. So we have sustainability, sustain, and survival development. So according to Paisley 1997, development is called as sustainable if the utility T, or our current utility, is smaller or equals to utility maximum, and this should always be the case. So what is UT, or current utility? So if you look at here, you have small t, right? So small t refers to time series data. When we talk about cross-sectional data, we are dealing with small I, but here we are talking about small t. So this small t refers to the present times, or our current utility. If you want to refer to the previous time or yesterday, so we can write t minus 1. If you want to refer to the future times or tomorrow, we will write t plus 1. So ut here refers to utility level of time t. Okay, so what is this utility maximum? So this is the definition. So it is our maximum utility which can be held constant forever from time t onwards, given production opportunity available at time t. Okay, so development is sustained if, let's say, the utility, so you have a small t here, not really small t, you have a dot on top of your utility. So what is this? This is the rate of change of utility at time t. So the rate of change of utility at time t should be smaller or equals to 0. Okay, so we call it sustained development. Okay, and the last one, development is called as survival if our current utility is smaller or equals to utility survival, and this should always be the case. So what is this utility survival? You can see the definition is here. It is our minimum utility level consistent with survivals of the given population. For your information, our utility depends on so many variables. Okay, for instance, it depends on our consumption and income and many other things as well. In other words, if let's say our income is increased, the utility should also be increased. Okay, if let's say the utility is a function of consumption alone, let's assume that only consumption depends our utility. So what happened? So we can define our development as sustainable if consumption or current consumption is less or smaller than utility maximum. And we can also define the sustained development if our rate of change for consumption is smaller or equals to 0. And for the survival, it can be defined if consumption, current consumption, is lesser or equals to utility survival. So these are the definition given by Pezzi for the developments. Okay. Based on the definition that we have learned in the previous slide, how would you rank the alternative time path over many generations? So we are talking about 100 years of generation. So based on this time path, which one do you think representing sustainability? So should we choose the first time path, or perhaps the second, or which one is the best to represent the concept of sustainability? Any idea? There are three criteria of sustainability. The first one, we call it non-declining consumption. So this is the common criterions used by economists when they talk about sustainability. If you look at this diagram, consumption path over time. So you have many types, many shapes of consumption path over times. So based on these concepts of non-declining consumption, which consumption path fulfill our criterions? So the first one, nope, it doesn't fulfill our criterions of non-declining consumption. Second one, yes. The third one, you have up and down, nope. And the next one, it is a static or constant consumption path. So because it is constant and there is no declining or decreasing of consumption, yes, it fulfill our criterions. The next one, yes. And the following one is yes as well. So based on this consumption path, consumption number 3, number 1, number 5 and 6 fulfill the criterions of non-declining consumption. Okay, there are some arguments or critiques about this criteria to explain our sustainability concept. The critic says that how large the non-declining level of consumption, isn't it? So do you consider such a very large declining or small declining in consumption will also mean it is not sustainable? So economy is considered sustainable using this criterion, even though their living standards are extremely low, provided that they do not get any lower. So this will prevent the development, isn't it? So in the case of Japan, for instance, they are actually a developed nation, right? But if let's say their consumption is decreasing, a very slightly decrease in consumption because they are very concerned with the impacts of their consumption on the environment. So can we say that they are not sustainable in terms of their development? Can we say that? How about India? Even though it is a low income countries, or we can say it is a poor income countries, but their consumption is gradually increased even though the increment is small. Can we say that they are achieving sustainable development? So these are some of the arguments made by the critics on defining sustainability using non-declining consumption criterion. Okay? The second criterion for sustainable development is called as survivability. So we have to get at least survival consumption. It is the minimum level of consumption consistent with survival requirement. So where is this survival consumption? When you look at this diagram, you have it here. So this is the line for survival consumption. All the time consumption paths on tops of this line are actually qualified for fulfilling survivability criterion. Okay, the last criterion to fulfill the sustainable development is minimum condition. So minimum condition is this one, minimum consumption. So this is the line for minimum consumption. All the consumption paths above minimum consumption are qualified, are fulfilling the minimum requirement. So C4 is qualified, C3 is qualified. How about C2? C2 is not qualified because if you look at here, it falls below the minimum consumption line. Okay, so now which path satisfied three criteria, all these three criteria? So we have non-declining consumption, survivability, minimum condition. Which one? If you look at the first one, this is declining, so it doesn't fulfill the first criterion. So how about the second one? Yes, it is not declining. The next one, it is declining. So this is fine because it is static. This one, C5, it is increasing. Okay, it fulfills the non-declining. How about, does it fulfill the minimum condition? So this is the minimum condition line. So it falls below the minimum condition. So it doesn't fulfill the third criterion. How about C6? It falls below the minimum condition. It doesn't fulfill. Right? So in this case, there are two time paths that fulfill the conditions of these three sustainable development criteria. Okay, so which one of the time paths maximize conventional utilitarian welfare function? Okay, so think about it and we will discuss this in the next class. Okay? Let's discuss on the various definitions of concepts of sustainability. A sustainable state is one in which utility or consumption is non-declining through time. So this definition is commonly used by many economists. Second definition. Sustainability means resources are managed so as to maintain production opportunities for the future. So this definition is given by Solow. For those who are taking economics, you should know who Solow is. He is the one who developed or introduced growth model. The next definitions of sustainability is resources are managed so as to maintain a sustainable yield of resource service. So what is sustainable yield? It means that our harvest rate should equals to natural growth or growth rates. The last definitions of sustainability is it satisfies minimum condition for ecosystem resilience through times. So based on these definitions of sustainability, do you have any comments on the concepts? Is there anything you want to say about this definition given by the scholars? Okay, so we will discuss on the comments, on your comment in the next class. Okay. For your information, Solo disagreed to conserve resources for future generation. If you still remember in our previous discussion, we talked about resources, right? So resources can be divided into two. The first one we call it flow and the second one is stock resources. So you can use your flow resources as much as you like because our current consumption will have no effects on the future resources. However, when we talk about stock resources, you have to be very careful. Are we talking about renewable resources or are we talking about non-renewable stock resources? If you want to use non-renewable stock resources, you have to be very careful because your current consumptions on the non-renewable resources will affect the availability of the future resources. Okay, but for Solo, he is more interested in the current opportunities, not on the stock resources. According to him, to ensure all generation can enjoy as we have today, depletable resources shouldn't be used, or should we reduce the consumptions of these non-renewable resources? For instance, we are talking about oil or we are talking about coal consumption. Currently, our production and manufacturing are heavily depending on them, isn't it? So if you want to reduce the consumptions of oil, if you want to reduce our current consumption on coal, it will affect our economic growth. So for him, it is not making sense. It is not reasonable, isn't it? So Solar said it is difficult to forecast the preference of the future generation. Okay, for instance, currently we are using oil. Perhaps in the future we may not use the oil anymore. Currently, okay, in the previous time, our father, our grandfather, they prefer to use bicycle to go to their works or to go anywhere. In our current time, we prefer to use our private cars, isn't it? But in the future, perhaps our son or grandsons, grand-grandsons prefer to use luxury public transport. So the preference of different generations will be different according to Solo. Yes, we acknowledge that. And the technology capability of the future generation will be different, right? So our current technology is actually, we can say it is advanced, but in the future it will be more advanced. Okay, so with this technology capability, they can do whatever they like, even though they have small number of resources, but they may make use of it at the maximum capacity. So for your information, Robert Solow is somebody. He won a Nobel Prize winner. So you have to think about his argument because his arguments are also making sense to us, isn't it? Sustainability can be illustrated using a simple optimal growth model using productions of non-renewable resources. Okay, here we are talking about intertemporal or intergenerational social welfare function. This is the examples of two-period problem, or we can say this is the examples of two generations. So our welfare function is a function of current utility or utility of the current generation as well as utility of the future generation. So what is this W? W is weighted average of utility for each generation. So specific functional form used by utilitarians can be presented here. So the welfare function is equals to pi of the current generation multiplied with the utility of the current generation plus pi and utility of the future generations. So what is this pi? Pi is weight used in summing utility over generation to obtain a measure of social welfare. And pi is also known as utility discount factor, where our current pi is equals to 1 and the future pi is discounted or equals to 1 over 1 plus rho. So what is this rho? Rho, for your information, is just some discount rate. Since we are working with utility, so this row is utility discount rate. So when we plug in our current pi as well as the future pi into our original equation, we will get the welfare function equals to utility at period 0, or we can say current utility plus the future utility with some discounting. So time discounting for rho should be bigger than 0. If let's say our rho is equals to 0, basically we are not discounting. So why do we discount? Because the future utility count for less than the current utility. So if we have many years, or if you want to generalize our equation, so we can write our social welfare function into this form. So the first year we are not discounting because our rho is into the power of 0. In the second year we are discounting and our rho is into the power of 1, and all the way out to period t. Okay, so mathematically discounting is just the opposite of compounding. So what is compounding? Compounding is how much we get the interest over time. So if we work backward, we will get the discounting. Okay? We can also write our welfare function in terms of infinite time horizons. So summations of all these things, we have the current year until infinite year, and then we also have utility discount factor. Make sure that you are not confused between utility discount factor and utility discount rate. So pi is actually our utility discount factor, and pi equals to 1 over 1 plus rho into the power of t, while utility discount rate is our rho. In continuous form, we can also write our welfare functions in this form. So you will use the integral symbol, and then our pi will be written in exponential form. So you will have e into the power of pt. Okay, so this welfare function should be minimized and subject to the following constraints. So the first constraint is K equals to Q minus consumptions. So what does it mean? So Q here is actually our output. So in other words, we can say output can either be used for consumption because you have to minus consumption, or investment or capital. So you can use output for consumptions or capitals. Okay, second, so we have the rates of change in stock equals to minus R. So R here refers to your natural resources. In other words, we can say natural resources used here is non-renewable because you have minus. Means that the more you use the natural resources, it will be decreasing. That's why you have minus signs. And stock size decreased by the amounts of natural resources used. And the last one, we have S bar. So S bar here is the natural or the initial stocks. So summations of all the resources used shouldn't exceed the initial stocks. So when we talk about many generations or perhaps 2 generations, so we have to manage it well. We have to manage our resources in such a way that our use of resources shouldn't exceed the initial stocks or initial resources. Okay? Let's discuss the concept of sustainability using a few diagrams. So we are talking about sustainability under constant consumption given three production functions. So the first production function we have Q equals to alpha K plus beta R. So Q here is our output, K is our capital, and R is the natural resources. When R equals to 0, our Q or our output equals to alpha K or alpha capital. What does it mean? It means that resources are not essential or not important here because our output can be produced using K or capital. So in other words, we can say that constant consumptions of non-renewable resources in production is not feasible, right? Because the output can also be produced using capital only. So K or capital is perfect substitute for resources. So conservation of resources is not necessary. Okay, so in this case, what can you say about these functions or this production function? We can say that this production function is not sustainable because we don't have the conditions of constant consumptions of resources. Okay, so it is not feasible to implement to use this production function. The second production function is Q is equals to minimums of capitals and resources. Right. So here Q is whichever is the smaller of K, capitals and resources. So for instance, if resource input, which is our R1, and Q1 is the maximum possible outputs. Okay, so where is our R1 in this diagram? So R1 is here. So to produce Q1, we will use R1, right? The smallest of R1. If let's say we want to use the capital input, the capital input is very high. So comparing between capital input and resource input, definitely we will use resource input because resource is the smaller. Okay, so in this case, resource is very essential in production and substitution is not exist or not possible because you cannot substitute R1, which is the smallest input, compared to K1. Okay, so total productions over all time cannot exceed initial stock. Remember that. So whatever we produce, our consumptions of resources shouldn't exceed the initial stock, which is represented by S bar. But our S bar here is finite. Remember, our resources is limited or finite. It is not infinite. Given infinite time, because we are talking about many generation, right? So considering this, the stocks of resources will fall because we are consuming it using different periods of generation. So when the stock fall, definitely our consumption will also fall. So in this case, we can say that our consumption is declining. So it is not sustainable, right? The third production function is Cobb-Douglas production function, where the output equals to capital multiplied with resources and the alpha plus beta should equals to 1. Here we assume that substitution is possible between capitals and resources in production. Here we are talking about Cobb-Douglas production function with constant return to scales. Okay, so we are assuming that our alpha should be bigger than beta so that we can get constant consumption. Okay, so our output should be set equal to 0. So when the output is equals to 0, it means that resource is essential. Resource is important. But given enough capital and our alpha is actually bigger than beta, so the output can be produced with small level of resources. So we can say that capital accumulation can exist and consumption can be maintained constant forever because we are using a small number of or small amounts of resources so that the resources can be used and it will not be decreasing. Okay. The previous slide that we have discussed is called as Hardwick rules. So constant consumption could be obtained from a finite stock of non-renewable resources given essential use in productions. So Cobb-Douglas production function should be where our alpha is bigger than beta. So substitution is possible between capitals and resources, and we have to follow the constraint. Intertemporal efficiency conditions should be met, and resources are extracted by perfect competitive firm with perfect foresight. Okay, at every point in time, total rent arising in the resources extraction industry should be invested in the reproducible capital. So our capital is equals to total rent from resources extractions. Okay, so what is this unit rent? So unit rent is just the price of extracted unit cell minus the marginal cost of extraction. Okay. Sustainability from the ecologist point of view. In ecology, normally they use the term sustainable yield or sustainable catch. So it is commonly used for fisheries. So what do we mean by sustainable yield? So basically, our harvest rate should equal to the size of natural growth rates of our resources. So here the stock size is constant, or in other words, resources can be used at a constant rate. So this is the correct rate of harvest. If you look at our diagram on the right side, so at S1, when our stock is at S1, the harvest rate should be at H1. So this point is the sustainable yield, because whatever we have the stock, we harvest it at the same rate. Okay, so we call it sustainable. If let's say our stock is at S1, but then we harvest at H2, so this is not sustainable. So definitely our stock size will fall. Okay, so when the harvest rate is more than natural growth, so the stock will go extinct. So at this point, we call it maximum sustainable yield. So S star here is the optimum stock size. Okay. Another term to explain the concept of sustainability from ecologist point of view is resilience. So resilience means capacity of an ecosystem to respond to exogenous disturbance by resisting the damage and recovering quickly. So if you look at this image on your right side, we have the conditions of we call drought resilience. So during the drought periods, so many trees and grass are gone, but later on, when the drought period has ended, they start flourish and grow quickly. Okay, so we call this condition as resilience. They are able to absorb all this disturbance, and later on they can grow quickly. Okay, the last term to explain the concept of sustainability, we have the terms of steady state economy. So what is this? This is a constant stock of physical wealth and population. So when we set steady states, means that our economy is static, okay, in a static condition. So when you talk about your population, you will have a low birth and low death rate. Okay, so this is what we call, or what we explain, the terms of sustainability from the ecologist point of view. Before we explain on the origins of sustainability problems, we will talk about how do we measure the performance of an economy or the size of the economy. Okay, so normally people will use GDP, or we call it gross domestic product, but many studies love to use real GDP instead of just the nominal GDP, because when we use real GDP, we can remove the price effects in a country over time. Okay, but if let's say we want to study for a cross-country comparison, so definitely we should use GDP in purchasing power parity. Okay, so for economic growth, if let's say we want to measure whether our economy has achieving the growth at a certain rate, so we will refer to our GDP. So we can say that increase in the real GDP is translated into economic growth. Why do you think most economists love economic growth? If you look at the first image, you have a few kids who are enjoying their meals and sharing one cups of rice with everyone, and they look very happy. And the second image, you can see there are two kids who are enjoying their meal as well, and they have various types of food on their plate. Even though their face is less grateful or less happy compared to the first image, this is something that economists cannot capture, but we can see that they have almost everything, almost sufficient nutrition in their plate. So this is why many economists love economic growth. Economists believe that economic growth is the solution to poverty issue. When we have economic growth, definitely we can increase the size of the cakes and it can be shared with many people. However, our resources are scarce and also limited. And when we want to have economic growth, we need this input, we need these resources to develop, to increase our economic performance. Right. So how can we go about it when we want to have economic increase in economic growth? Don't you think that we will have a problem with increased pollution? Because if you want to develop, you have to manufacture many things, and manufacturing process is very polluting, very polluted. So this is the problems of sustainability. How can we want to reduce or alleviate poverty in such a way that we will not affect or harm the natural environment as well as the future economy and future generation, right? Economic activities take place within and also is part of the system, which is what we call earth and atmosphere. So this system is called as environment. So the economy is located within the environment, and our activities, all types of activities, depends on the resources that we found in environment. So basically we can say that economy and environment is interdependent on each other. Without the environment, our economic activity cannot be done, and we cannot do anything without the resources. So definitely, if we want to grow, if we want to have economic growth, we need to rely on the environments or the resources provided by the environment. The environment interact with the economy in four ways. First, the environment act as resource base. In other words, the environment provide energy as well as input in our production. Second, the environment also act as amenity base. So we will get direct source of utility from the environment. Definitely you will feel happy. You will get peace of mind by enjoying the nice scenery of beach or waterfall, isn't it? Next, the environment also act as waste disposal. Whatever we produce, whatever we consume, we will dump to the environment. So the environment will become our sink of all these kind of pollutions. Next, the environment also will provide the life support function. We call it ecosystem service, like air, clean air, water, fish, and so on. So basically the environment has economic values, even if the values are not registered by the market. Okay, so we get all these benefits from the environment, but many of us didn't really appreciate the value of our environment. Materials balance principle says that matter or something can neither be created or destroyed. So economic activity cannot, in material sense, create anything. Definitely you cannot create something out of nothing, right? So you have to start with the environment or the resources. So it involves transforming material extracted from the environment so that it is valuable to human being. So if you look at this chart of law, so we will start with the environment. Okay, so this environment can be directly consumed by the household. For instance, like vegetable, you can plant it and consume it directly. And this environment can also be produced or manufactured by the firms, and then from the end product, the firm will sell it to household, and we also can consume it. Definitely the consumption from household and the production from the producer will create residual. So this residual will be sent or thrown to the environment. And all our residuals from the firms and from the household can actually, some of them can be recycled. Okay. Production function specification. Many of you are familiar with the first equation. Output is a function of labor and capital. Definitely you have to use labor and capital to produce your output. However, according to the materials balance principle, you cannot create something out of nothing. Labor need to have an input to produce the output. Therefore, you must have materials input in your production. So, because of this, we derive the second equation. Output is a function of labor, capitals, and resources. However, resources is normally used for resource economics. Are we talking about resource economics? No, we are talking about environmental economics. What is the heart of environmental economics? Environmental economics focuses on the economics of pollution control. So we derive the next equation. Output is a function of labor, capitals, and waste. So can we say that waste flow is an input in your production? Well, definitely no, but you can look at it this way. Reduction in your waste generation will definitely affect your output, your quantity produced. Okay, so let's make it general. So your output is a function of labor, capital, and your waste, as well as ambient. So A here is the ambient concentration level of pollutant, and this ambient concentration depends on waste emission across all firm. Okay, so based on this equation, basically it contradicts with our materials balance principle, since waste is actually created from economic activity. Remember, economic activity cannot create something or anything out of nothing. So definitely you have to have the base. You have to have the resources. So the last equation is output is a function of labor, capitals, and you also have what is M? Waste. And this waste is actually created from the resource used. So you have the resources, and from the resources that you use, you created the waste, and then you have the ambient concentration level of pollutant out of your waste emission. So this is the correct equation for production function. Okay, now my question is, why don't we use the correct equation? Why it is commonly introduced to us that output is a function of labor and capital? Why not all this correct equation? Any idea why we didn't use the correct equation? So there are two answers to answer this question. The first one, nothing much lost by using the incomplete equation. Okay, second reason, why do we use the short form? Because it simplified our analysis. Okay, if you want to list down all the details components of the equation, it will somehow complicated our analysis. Okay, driver of economics impacts, we have I equals to pet, or you can also say iPad. So what is I? I refers to the environmental impacts such as pollution. So environmental impact can be measured using mass or volume. Second component is P. P refers to population size. And the next one is A. A is affluence. Affluence can be measured using GDP per capita. And the last one is T. T is technology. Technology refers to the amounts of resource used or waste generated per unit production. Okay, so I should equals to PET, means that the impacts of the environment should equals to the population size, affluence, and technology used. Okay. This equation refers to our iPad. So pollution is your I, environmental impacts. While this is your P, population, multiply with your affluent. Okay, so affluent will tell you how rich the country is per person. So affluent can be measured using GDP per population. It also tells you who engage in the economics activities. And then you will have your T, technology. Technology is measured using pollution over GDP. Or in other words, it will tell you how much pollution is created in producing your GDP. For instance, if let's say you are using green technology, so you will perhaps produce low pollution. So your pollution is measured using tons. Okay, your population is measured using the number of people. GDP is measured using dollars or ringgit per year, okay, and the remainings are the same. So if you look at this equation, as if like there is some item that can be cancelled off, okay, so you have population here, you can cancel with this population, you also have GDP here, and you can cancel off with this GDP. So now you will get pollution equals to pollution. So we can call this iPad is an identity, okay, pollution is equal to pollution. Clear? At the current time, our population is about 6.5 billion. The affluence is about 9,000 plus. The technology is zero point zero 0.00 something, and the impacts, environmental impacts in terms of billions of tons is 28 point something. So how to get the value of 28.98? So remember we have I equals to pad, or we can say iPad. So to get the value of I, or environmental impacts, the population should multiply with affluence and multiply with technology. So you should get the value of 28 point something billions of tons. Okay, the second scenario, let's assume that our affluence and technology is constant. You can see that we have bar on top of affluence and technology, but the population increases by 50%. So our population previously is 6.5, and then because it has increased by 55%, so it becomes 99.7. Okay, so this is in terms of billions. And our affluence and technology is constant. So what is the value of the I? So you just have to multiply 9.7 with 9,000 plus and zero point zero 0.00 something, and you should get the value of X. Okay, so you can compute it at home because it is not that hard. The third scenario, we have our technology constant, okay, and then our population increases by 50%. So the same, previously it is 6.5, now we got 9.7 billion, and our affluence is double. Okay, so the affluence previously is 9,000 plus, now it's become double, so you got 19,000 plus. Okay, so you should get the value of your impacts or environmental impacts equals to 86 point something billions of ton, because the affluence and population has increased, so the amounts of pollutions or the amounts of environmental impact should also be increased. Okay, the last scenario, our I, or environmental impacts, is at the current period. Okay, what is our I in the initial periods? We have 28.98 billions of ton. Okay, so it is the same with our initial value. So our population is definitely increased by 50%, so you have 9.7. Our affluence increased by double, we have 19,000 plus. And what is the value? What should be the pollution emission per unit GDP? So what is the value for our Y? Since everything has increased, the population, the affluence, okay, and we want to make sure that our impacts, environmental impact, the I should maintain as the original value. So what is the value for our technology? Okay, so definitely your technology should be decreased to make sure that you will get the initial value of the impacts. Okay, so you can just compute it at home. Okay, this is the trends of global CO2 emission from energy use. So we are talking from year 1971 until 2035, and currently we are here. And in the future, we are expecting that these two giants, China and India, will contribute to CO2 emission. However, at the present time, their contribution to CO2 emission are actually much lesser compared to the developed countries. Okay, if let's say the business as usual, we can expect that the CO2 emission will keep increasing, right? Okay, so many developed countries are saying that, well, these two countries should reduce their CO2 emission, but China and India also have their argument. They are saying that Why should we reduce our CO2 emission? Because the previous CO2 emission, if you can see here, the previous CO2 emission was contributed by the developed countries. Since now they have developed and they wanted to prevent other countries from develop by emitting CO2 emission. So the argument keep continuing until I'm not sure when it will be ended, right? Because of the growing issues of CO2 emission, Yoichi Kaya has developed Kaya identity. So previously we have I. I refers to environmental impact. In this Kaya identity, we wanted to be specific. So the pollution refers to CO2 emission. This C is CO2 emission. And then we have population and GDP per capita or our affluent. And these two things are actually referring to our technology. Okay, so the first item, we have energy per GDP or over GDP. So we can say this is the energy intensity of economy, or in other words, this is the energy used to produce our output. And the last term we have C over E. So C here is the CO2 emission while E is the energy. Or we can say this is the carbon intensity of energy. In other words, this is the carbon emitted from the energy used. Okay, so why this is also an identity? Because you can cancel some of them. So population can be cancelled off with population. GDP can be cancelled off with GDP. Energy can also be cancelled off with energy. Now we only have CO2 emission equals to CO2 emission. So we will get the result of identity. Okay, so if you have a growing economy, how to achieve emission reduction? Okay, any idea how can you achieve emission reduction? So first, what do we mean by growing economy? So this is the growing economy. So when you look at this equation, growing economy means that our population is increased and our GDP per capita is also increasing. So when you have this kind of problem, what should you do to reduce the emission? Definitely the latter two, which is the first and the second, should be reduced. Okay, so you have to make sure the latter two should fall by improving the energy efficiency or moving to low carbon technology, or perhaps you want to go for nuclear power, solar or wind power. Okay, so you have to make use of your technology. Okay. Does environmental quality necessarily deteriorates as economies develops? In other words, can we say that there is a trade-off between economic growth and environmental quality? Let's see some observation. Cities in rich countries are cleaner than they used to be. So let's look at these two images. The first image refers to pollution in the Victorian Manchester. In the old time, the cities in Manchester was so polluted. You can see that this pollution is very serious. At the present time, we can see that the countries or the cities are actually cleaner and cleaner. Based on this observation, we can see that once the country has achieved economic growth, the environmental quality will be getting better and better. Right. So how about the cities in developing countries? When you talk about Beijing, when we talk about Jakarta and India, in Beijing, you can see that they are suffering from serious air pollution issues. In Jakarta, they are also suffering from air pollution as well as waste generation. In India, they are also suffering the same thing. So how about this condition? How about this scenario? Should can we say that economic growth and environmental quality can go together, or there is a trade-off between these two? Any idea? Environmental Kuznets curve will explain the previous scenario. So there is an inverted U-shaped relationship between growth, which is measured by income per capita, and environmental quality, which is in terms of pollution. So it says that up to a certain point, growth will make environmental quality worse, but after a turning point, so further growth will improve the environmental quality. Okay, so we will look at the diagram in the next slide. Environmental gooseneck curve can be illustrated using these diagrams. So on your y-axis, you have the pollution produced, and x-axis, you have economic growth. At the initial stage, your income per capita is very small and the pollution produced is also very small. So you are in the agricultural sector. Okay, that's why your return is very small and the pollution produced is also small. Once you are moving to these periods, we call it industrial sector. So your income is a bit higher compared than before, and then the environmental impacts or the pollution produced is also higher. Now you are using machine in your production. That's why you are producing more pollution and your income is also higher. After this turning point, you can see that your income will be even higher, but the pollution is reduced. So we can say that at these periods, you are in service sector. So in the service sector, it is very clean and green. That's why your pollution is reduced, but your income is quite high. Okay? That's why you have this kind of shape. Class exercise. I love to have this session with everyone, especially face-to-face session. So the first question, what could cause an EKC, environmental gooseneck curve, style downturn in a pollutant? So why you can have an increasing shape and then later on decreasing? What is the reason for this shape? And the second question is the EKC a good policy guide for everyone? So think about it. What will be your answer for these two questions? These are some potential reasons for an EKC downturn. The first one is because of structural change. So you start with agriculture and then you move to industry and lastly you move to service sector. That's why you will have an inverted U shape for EKC. The second, when you have economic growth, definitely you will have enough capital to invest in technology. So you will have a better or improved technology. And because of this improved technology, you can have a better abatement capacity. Next, when you have economic growth, definitely you will have high income, right? Remember, environmental good is a luxury good. So when you have a high income, you can have a purchasing power, right? So there is an increase in the demand for environmental quality or environmental good, and you will have a better or greater public awareness on the pollution effects. So because of that, you will somehow push and force the policymaker to formulate a stringent policy. The next one, you will have this term what we call pollution haven. So what is this term? So it means that when a country put environmental policy in place, especially the developed countries, because they have the purchasing power to demand for a better environmental quality, so they ask for a stringent policy. So that's why you have this issue, pollution haven. So when a country put environmental policy in place, the polluting industries, polluting company will move to other countries, especially the poor countries, and enjoy a competitive advantage. So these polluter cannot stay in their own country because they have to face this stringent environmental policy. So they have to move to a poor country and do whatever they like. That's why in the case of Manchester, the current cities are cleaner and greener because their polluting countries, their polluting industries are moving somewhere and enjoy their activities. Okay? And the last one, because of automatic or indirects. So this is the case for Sweden. Previously, Sweden was very concerned about their energy security. Right. So because of their concern on the energy security, so they move to nuclear power. But indirectly, when they are moving to nuclear power, the environmental quality become greener because nuclear power is not producing pollution. Okay. So the last question, is the EKC a good policy guide? In other words, should we just relax in the knowledge that economic growth will solve environmental problem? So as you know that EKC has an inverted U shape. So once we keep moving, we will have a higher income and a lower pollution. So should we do nothing about it? The answer is definitely not. because not all country will have this EKC shape, and not all pollutant will exhibit EKC shapes. So if you look at this diagram, we are comparing the case of Australia and Sweden, and we are talking about 1951 until 2008. So in the case of Sweden, you can see that Sweden has an EKC shape. So why is that? Is it because Sweden has achieved economic growth? The answer is no. Remember our previous discussion, Sweden has changed to nuclear power, and nuclear power is very clean and green. That's why Sweden can enjoy a better environmental quality. So how about Australia? Australia is a developed country. Australia has achieved economic growth, but what happened? It doesn't reflect, it doesn't show that Australia has achieved the EKC shape. Okay, so you can see that the pollution of Australia is increasing every year. So this is the example that not all countries will exhibit this EKC shape. So by learning EKC theory, so you shouldn't be happy that thinking that economic growth will solve everything. Okay, we have to do something to tackle or to solve our environmental problem or issues. I would like to express my gratitude to Paul Burke for providing some materials for this lecture. Okay.